I'm still here in prefix equals starter, and as you remember, the last video, what we did was we started designing this function. We built a cross-product table because it consumes two arguments, both of which have a one of in their type comment, and that table helped us know how many test cases we would need. So let's see, signature purpose stub examples. It's time for the template. What's the template going to be for this function? It isn't going to be enough to go get the template for list of string, because there's two list of strings. And it isn't going to be kind of enough to just take the two list of string templates and put one after the other, because that sort of doesn't make sense with a cond. We're going to have to do something else. Again, let's just do the easy part first. The question is, what goes in here? Well, the cross product of type comments table can help us figure that out. If we go back and look at the table, it tells us, look, there's four cases. There's the cases where both lists are empty, the case where list A is not empty but list B is, the case where list B is not empty but list A is, and the case where both lists are not empty. There's four cases, and in each case there's something true about the first list and something true about the second list. So we can sort of imagine, gee, there's four cases, it's going to be a four-case cond. Now let me give you a bit of warning here. We're going to do it one way, and then I'm going to simplify it. Pay close attention to what's about to happen for the next 2 minutes, but I'm going to then show you that it's not the best way to do it. But it's really important to understand the best way to do it to see the next 2 minutes first. If we just look at the table naively, or I should say if we just look at the table without thinking about the results, the table tells us there's four cases. And we could build a template for the four cases something like this. Let's see, there's going to be a four-case cond. And I'll put the table here off to the right so we can see what we're doing. The first case is the case where both lists are empty. And something happens here. Let's see, the second case, the upper right case, is the case where, and here's a predicate you may not have seen before, but it does exist, cons question mark of list A. It says, is that a cons? But list B is empty. And then something's going to happen here. And it's going to involve list A somehow. Okay, and it's probably going to involve the first and the rest of list A. We'll get to those details later. And then here, this would be and cons question mark list B, empty question mark list A, or if you want to be consistent in the order, you could maybe write this as empty question mark A and cons question mark B. And something's going to happen there with B. And in the last case, they're both conses. And you can make that work out. That will actually work, and it'll work properly. You'll end up, I've got an unbalanced bracket here somewhere. There it is. I got another unbalanced bracket here somewhere. Oh, there it is, right? That one's unbalanced. And that one's unbalanced. And you can make that work. You just need to be careful to use the compound rule here on list A and list B. And you'll end up using compound and self-reference. And you've got to use the compound and the self-reference rule here on both list A and list B. I don't want to do that yet, and I'll show you why. This is a four-case cond. This would work out. But there's a slightly more clever thing to do, which is this. Let's go back to the table. So let's not do this. What I'll do is I won't throw it away. I'll just comment it out. Let's pretend that we didn't do that. Pretend we didn't do that template. We're going to go back to the cross product table. Now if we work with the cross product table and the check expects, we can figure out what the answers should be and we can put them in the table. Okay? So let's look at this case. They're both empty. What's the result? Well, the check expects tell us that in that case, when both lists are empty, the result that we want to produce is true. And let's see, when list A is not empty but list B is, the check expects tell us that the result we want to produce is false. And when list B is not empty but list A is empty, the check expects tell us that what we want to produce in this case is true. Now what do the check expects tell us about this case? This is the complicated case where both list A and list B are constants. They have elements. Well, if we look at the check expects, this test tells us that if the two start with the same element, if the two start with the same string, then we kind of need to look at the rest. Because in this case where it's XX, it ends up being true. But in this other case where they differ later on, it ends up being false. So we need to look at the first elements and kind of do the natural recursion. So we could just put an informal note here that says something like firsts are equal and the natural recursion. We're just going to basically say check that the firsts are equal, and if they are, check the natural recursion. This is just kind of an informal note. But now this table is going to be huge for us. Let's see why by turning back to the code and the template. First thing I'm going to do is I'm going to read the template right off the table. And the way I'm going to do that is to observe something really important, which is that in this table, there aren't 4 cases. There are actually 3 cases, because both of these cases are true. And I could actually treat this, instead of being 2 boxes, as being a single box, just by eliminating the line between them and sort of drawing a blacker box around them, or you can just draw it with a pencil with a circle if you want. But now there's 3 cases. So I'm going to have a 3-case cond. Here we go. I'm going to have a 3-case cond. And the way I do this is I always start with the biggest box. So since this left column here is the biggest box, I'm going to start with it. Now what is it that's a test for that column? What's true about that entire column? Well, what's true about that entire column is that list A is empty. List B is sometimes empty and sometimes not empty, but in that entire column, list A is always empty. So I'm just going to say empty question mark list A. And since it's just a template, I'm just going to put that there for now. And now, what I can do to the table is I can completely eliminate this column from the table. I can cross it out as if it never existed. What that's saying is, listen, from now on, I can ignore the possibility of list A being empty. And that's going to be really important. From now on, I know that list A can't be empty. This column is gone. So now what's the next best case to do? Well, this case of false seems simpler to me, so I'm going to do that one. You kind of head for the lower right of the diagonal last, because it's usually the most complicated case. So now, what is it that's true about this case? Well, what's true about this case is I no longer need to consider the possibility that list A might be empty. I know that list A is definitely this case. It's definitely this cons. So the question is, what distinguishes this box from this box? And what distinguishes this box from this box is just whether list B is empty. So the question here now is list B empty? And we'll put some dots there. Now going back to the table, there's only one cell left. So I can say else. And we'll put some dots there. But now let's go back to the dots. Now I could template that set of dots. I know that list B is a cons, but if I look at the table is telling me that the result in this case is true. So I'm not even going to bother to template it. And similarly, for this set of dots. I could template this case. I know that list B is a con, so I could use the compound rule and the self-reference rule, and I could build what really belongs in these dots. But when I look at the table, it's telling me, look, the answer is going to be false. So there's no use building all that stuff if I'm just going to replace it with false. I'll just put false here. But now if I look at the table, this case, this last set of dots is complicated. So let me go ahead and template that properly. I know I've got both list A and list B to work with, and they're both still conses. So let's see. It's going to be something like list A, list B, except list A is a compound. So first of list A is a string, and rest of list A is list of string. But that's a self-reference back to list of string. So this needs to be something like fun for LOS, except no. This is going to be some kind of natural recursion. So right away I'm going to change this to prefix equal, rest of list A, and I don't know what the second argument is going to be yet. There has to be a second argument because prefix equal takes 2 arguments. Let's go look at list B for a second. Well, list B is con string list of string, so I've got to take the first of it, which will be a string, and I've got to take the rest of it, which is list of string, except again now that's a self-reference. So in a normal template, you would start putting fun for LOS here, except we're past that stage now. Again, this has got to be prefix equal. And what goes there? Now I'm kind of in a silly place. I've got 2 calls to prefix equal, neither of which has a second argument. What I'm going to do in the template is I'm just going to bring this up here. I'll get rid of this call. And just because it makes the order look nicer, I'm actually going to put that there. So now that's my template. Templating is a little bit more fluid notion now than it used to be, but all I've really done is adapted the rules we've used before and used the cross-product table to simplify. I can now read the answer right off of the table too. I need to ask whether these strings are equal. Let me go ahead and get rid of the comments, the type comments now. And here's the natural recursion right there. And I'm just going to put an and there. Let's try that. Oops, I forgot to comment out the stub. But now all 9 tests are passing. So look, an incredibly important thing happened here. Remember that the type comments produce the templates. If we follow the rules properly, the type comments predict the templates. That means that the type comments are a model of the resulting functions. They tell us something about the structure of the resulting functions. And in this case, we can take advantage of that by combining 2 models. We've got one set of type comments across the top part of the table and one set of type comments across the side part of the table. Those are the 2 models. We combine them in the table. We fill in what the code should do in the body of the table. And then we simplify the table by taking this column here and turning it from 2 cells into 1 cell. And then we generate the template and the function off the table. And we end up with 3 simple cases in the cond rather than 4 complicated cases. The technical term for this is simplifying at the model level. It's a huge idea in all kinds of science and engineering, and it's certainly a huge idea in software development. People who can do this, people who can say, wait a minute, I can think about that without having to look at the details of the code. I can simplify this program even before I type any of the code. Those people are software designers, as opposed to people who just type and pray. And you want to be one of those people. You want to be able to reason about code at the model level. This is a first example of that. It isn't really a first example of that because we've been doing that with type comments all along. But this is the first example where it really does some powerful magic for us.